welcome back to our channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Pablo, who has finished one of our courses that require a presentation for a certification. This will be the ROS 2 navigation in 5 days. And in this course of ours, at the end of it, there is a real robot project where students can connect to a real robot and test what they've learned throughout the course. So today, that's what we're going to see from our student, Pablo. How are you, Pablo?
Fine, are you?
All right. So yes, whenever you want, you can start sharing your screen and showing us what you've done with this course's project.
Sharing. Do you see it?
Yes, we can see a bunch of terminals and the robot in Arvis.
Okay, perfect. So what I'm going to show you is what I had to do for this navigation project.
Uh-huh.
So there was a first step where I had to construct to build the map for the navigation so the robot can localize and move in it. I'm not going to show how it was done, but here is the result of the map in gray and black. So we created a frame and saved it. And then I had to create the base for the navigation. That is the localization. So the robot has to find where it is to can move to another place. So we launch like a map server using loading the map that we built before, and then we like give an estimate pose of the robot here, and as you can see, the leader points and the robot position are not really well synced with the map. And we can see that there is the particle cloud that shows where the node thinks the robot is. It's like different statistical positions where it could be. So now I'm using the keyboard to move a little bit a robot. So with more data and different orientations, the node is able to like calibrate where it is. And as you can see, after half turn,
Yeah, that was really cool.
The node synced the point cloud and the map.
Uh-huh.
And the particles like shrinked around the real position of the robot. So now we have this setup where the robot knows where it is, and with a map well put in the right position. Then I had to do like a nav node that planification more node that calls different nav2 package options that do like path planning. That you give it a goal, and then the computer, the path planning, the nav stack, like calculates like the optimal path to reach the goal. So I'm going to show you first, like sending it a goal from Ervis. So as you can see, the robot moves where I tell him to go. And avoids the obstacles on the real map here on the right. But for the ROSject, I also had to do another node that like interacts with the path planner to send him how to say it, another goal. So here, for example, I'm going to send him a point that I saved before, like behind the spot name corner one, there is a file that that has the coordinates of the point.
Right.
So my node is going to send those coordinates, search the coordinates with this name in the file, and send it to the nav stack.
So previously known locations that you're going to. Okay.
And here it goes. Oh, nice. It reaches goal and goes to the position that I gave him before. After it's possible to give him and here goes with the example of another point. Oops.
Oh yeah, that's a new problem we see right there. We're just happening with the new obstacles.
So here it is. Here we have seen like a fail with the panel.
At the obstacle, yeah, you see, because the bottom part is thicker, so
yeah,
the nav2 actually thinks that it has space. So that's a good.
With the ones before, it hadn't this problem
because it
was a SIG base.
Yeah, I didn't think of that. So I'll include some instructions.
So nice. Well, that's what was asked for the ROSject. I had some difficulties during the realization of this ROSject. You have to know that I ended it in September, the first version, and like went on holidays. And when I came back, my version stopped working, and I couldn't find why. And it results, it's because there has been like the ROSject was in Foxy, the environment, and like there was a stability regression in between. That I wasn't that didn't show before I put the up to date the environment before coming back from holidays.
Indeed, yes. We'll go right into that after I'm done asking some questions of your project, because I think it's really important. And you were actually one of the students that alerted this to us, that created and made us improve the upgradability of our projects. So yes, we'll go into that. But first, I want to ask you a couple questions about the project, if that's okay.
Yeah.
So mostly you have, then you talked about creating a map, then adding the nav2 stack, and then the last part that you showed was a program to send the robot to predetermined poses, let's say. So can you show us each one of those components after the nav2? I think we can assume nav2 works really well because we can see it. But if you could show us the components of this predetermined location program center that you have made. So there are two components, right? You talked about it.
So the components are the localization and And the path
No, I'm
planning.
talking about the spot recorder program. So first you recorded some spots and then you
Yes.
send it to them. So we just want to take a look at how you did that.
Where it is. It has to be this
Spots
one.
to file. Yeah, that sounds like it.
Looks like. So it's the spot recorder is like built around a subscriber that is going to listen to the other topic of the robot. So the robot is sending us the data of where it thinks it is, thanks to its odometry. And reading this topic, we can like search what are the coordinates of the robot.
Right, based on the odometry.
Yeah. And so when I move the robot thanks to the keyboard to the location I want, and like I launch a script that makes it read those coordinates and then save them in a file.
Yes. So, all right. Okay, I understand. And did you have any problems? Did you remember matching the odometry coordinates to like the goal? Because they depend on different things, right? So
yeah.
Did you have any problems? And if so, how did you manage to fix those?
The problem to reach the goal comes from the path planner, like the controller.
Okay.
With the path planning, there is the path planner that calculates the best way to go to the location, to the goal. But after, there is another module that works, that is the controller.
Yes.
And the controller is going to send CMD velocity commands to the Turtlebot to follow this path. So it is going to, like if I send him a goal, it's going to say, okay, turn left, turn left, turn left, and go forward on this. And the problem is that this controller and the path planner have like a tolerance parameter in the config.
Yeah.
That allows to like make it easier to the robot to say I reached the goal. So instead of reaching exactly the XYZ coordinates, it's going, for example, what I made like a small diameter around the point, so the robot goes close to the objective, but doesn't spend 5 minutes doing a maneuver to try to reach exactly the point. At the first time when I made it, the circle was a lot bigger, so the robot stopped a lot before the goal, so it was a problem. There is something to know that isn't shown here in RVs because of the ROS environment. Is that it doesn't show the cost maps.
Yes, that's correct.
Like here around the map and around the robot, there is a global cost map and a local cost map that show like a gradient around the obstacles. And it was set up to like the diameter of the robot and a security plus a security margin to avoid that the robot thinks like the robot here, it's the center of the robot, but the robot is bigger. It has a bigger footprint. So if it goes too close to the wall, it's just going to have a shock.
Right. Okay. Okay. Do you mind stopping sharing your screen now, Pablo, so we can sort of take a look at each other here?
Here it goes.
All right. Okay. Well, congratulations. Really nice project. Really clear. And you talked about two things that I want to address. So the first one is the Arvis issue that you just said. That is an issue we have not been able to figure out based on the remoteness of of things, right? Because if you run it locally, as you can probably tell us, you can see these cost maps, right, in the simulation, for example. Once you do this, DDS, once you connect to the robot, you're actually connected to a remote PC. So now DDS, the underlying layer of ROS2, comes into play with the communications. And I think that's where the issue lies, where it's a visualization problem for RViz. So one thing to do that I always recommend people is to not completely rely on RViz, because you never know when things like this are going to happen. So a lot of students will come to me and say, hey, my navigation is not working. And they're right, because they're shown that they should see the cost maps, right, in RViz.
Yeah.
They do not see it. But if you go one step further and recognize these issues that, for example, RViz famously has, you can kind of take that one step further and say, is it really not working? Let's see. So, because if you think about it, if you have the local cost map, if you don't have the local cost map or the global cost map, your nav2 stack would probably error out and not run, right? So these are some of the processes that people have to keep doing in order to sort of stay ahead of the games.
At the beginning, I had the problem, like I had the controller, but without the cost maps implemented.
Right.
So
it runs into
it used to go too close to the center obstacle.
Right,
so
right. That's
it
another.
Used to touch it, and after putting the local cost maps and global cost maps, like first with the global, the initial trajectory was didn't go as too close to the obstacles, and after, thanks to the local cost map, even if it wanted to go a little closer, it couldn't, because it says, oh, in reality there is I sense an obstacle.
Yeah, that's true. All right, and then the other thing I wanted to mention is you talked about a regression issue that you experienced. Basically, the way this, let me try and explain it, see if I'm correct. We had this project for this course was made back when Foxy, the distribution of ROS2 Foxy, was the main one, right? And you created your project and tested it, and then came back from break and found that something was wrong, right? That it didn't work. So basically, we had to adapt our robot and our platform to be able to handle the next distribution, Galactic. But I want to ask, because I know we had a back and forth in our forum, which I invite everyone to participate in, that could you explain kind of like in very basic terms what was happening with that Foxy, and see if it's what happened to me when I went and tested it?
Like, if I don't do mistake, it worked correctly like one time or half time. Like, for example, sometimes when you launch some NavStack modules, it didn't just didn't launch.
It got
It
stuck
uh,
or
it
something, huh?
said that some things were missing, and like other times, it worked perfectly. You can send him like 2 or 3 times the goal, and it works, and then everything stops. Uh,
Right,
or
right.
sometimes it has a behavior that is not the one expected from the path planning.
But the main issue was that sometimes, like, it would work once, and then you kept sending goals, and it just wouldn't move. The robot would
Yeah.
just not move. Yeah, that happened to me as well, and I think it's important. We're going to actually thinking about preparing an issue report to NAF2 because this is since we didn't touch anything, we can assume that the Foxy distribution for NAF2 binaries, right? Because we install NAF2 with sudo apt install, NAF2 install it. And then inside of there, that's where all of those things should be handled. But uh, if anyone else has the same experience with Foxy NAF2, bring it over so we can create a report that they'll be able to fix it, because I assume there's many NAF2 stacks out in the world that work on Foxy, and maybe they found the solution that they can share, or maybe we can make that happen in the NAF2 binaries. So that's basically in a nutshell what has happened. Now you'll see that the project is in Galactic. That means you can connect to the real robot in Galactic, and probably this week we'll have it so you can also launch humble ROSjects and be able to connect to this this robot specifically. So I just wanted to mention that because I know you experienced the issues, and I wanted to talk to you about them. But other than that, Pablo, it's a really nice project, really simple, and I'm glad that it worked. Everything seemed to work really smoothly. The navigation was really good, which assumes that you spent time configuring it, which is mostly the most important part when you're launching NAF2 things. And the applications you build on top of them, like the spot recorder, is then up to you to
Yeah.
create. So I want to congratulate you again, and yeah, for everyone else that is watching, you can do what Pablo did here and introduce autonomous navigation to a robot in order to do whatever you want. So I invite everyone else to do what Pablo did here. And thank you very much again, Pablo, for your presentation. We'll see you around, hopefully.
Thank you.
All right, bye-bye.
Bye.